Hey students, this is lesson 633, arithmetic and geometric sequences. We are going to learn how to identify arithmetic or geometric sequences, how to write a rule for those, and also how to find the next term. So here's a good definition for you. A sequence is an ordered list of numbers. Each number in the list is called a term. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. This difference is called the common difference. To find the next number in an arithmetic sequence, add the common difference to the last term. Note, not all sequences are arithmetic or geometric. You can find any term of an arithmetic sequence if you know the first term and the common difference. Really, arithmetic sequences are just linear situations since you're always adding the same amount. Here's one rule for arithmetic sequence. Written in function notation, the nth term is equal to the first term plus the term number minus 1 multiplied by the common difference. Or, I like this one better, the nth term is equal, and we can write that in function notation also, is equal to the 0th term, which we're used to. And just so you recognize this, the 0th term is really the y-intercept plus, here it says d for the common difference. We're used to that as the slope. They're the same. And then n is the term number, and we're used to that just as being the x. So, so this is really no different than a linear equation, just kind of different letters. So you really can use this also. F of x is equal to, and I think that's what we'll do, the slope, which in this case is the common difference in the arithmetic sequence, times x, which is the term number we're on, plus the y-intercept, which in this case is the 0th term if we went back one more term. All right, so let's check out some arithmetic sequences here. Describe the pattern in each sequence. What are the next two terms? In A, it's a sequence where the first term is 4, and there's a common difference of 3. Oh, I said that wrong. Common difference is 2. And we get that just by subtracting these two. 6 minus 4 is 2. 8 minus 6 is 2. 10 minus 8 is 2. So, and then we also want to write a function rule for that, and I'm going to write it like this using function notation. And I'm going to use the letter A because it's an arithmetic sequence. So I'm going to say A sub n, A of n. So n is the input, and that's whatever term we're on, is equal to, we want to think of the common difference as the slope in this case. So we're going to multiply 2 times n. And then think about what number you would start with for a 0th term so that when you add 2 for the first time, you end up with 4. And that would be 2. And you can get that just by subtracting. If we go back one more from 4, we're at 2, and that's a 0th term. Because when we have an arithmetic sequence, I always think of the first number you see as the first term, second term is 6, third term is 8, and so on. If I put these in a table, the first term is 4, the second term is 6, the third term is 8, the fourth term is 10. We know that we need to get our y-intercept, we actually need the 0th term, and to get that we would have to subtract 2. So, all right, second sequence, we are adding 2, then we would be adding 6, then we'd be adding a heck of a lot more. We'd be adding 18. So if there is no common difference, this one actually has a common multiplier or a common ratio. If you do 3 divided by 1, you get 3. If you do 9 divided by 3, you get 3, and so on. So if we describe this, we say our first term is 1. and there's a common ratio, not a common difference of 3. All right? Oh, I forgot to write down the next two terms. This one would be 12 and 14. And 27 times 3 is 81, times 3 is 243. The second one, the function rule for that, since there's a common multiple, that's an exponential sequence. So we would say that that sequence, and I'm just going to use y for now for that rule, y is equal to, we would have to go back one more term, and to do that I'd have to divide by 3. 1 divided by 3 is 1/3. And then our common ratio is 3, so we multiply by 3. And this time we'd have to do it to the nth power, or the x power, to get the term value. All right, so problem 1, extending sequences. Describe a pattern in the sequence 5, 11, 17, 23. To get from 5 to 11, 11 minus 5 is 6. 17 minus 11 is 6. 23 minus 17 is 6. The pattern is adding 6. So it's an arithmetic sequence to the previous number. Next two terms would be 29 and 35. The function for this, let's use function notation here. Let's say a sub n is equal to the 0th term. If we went back one more, so if we did 5 minus 6, that'd be -1. That's our y-intercept. We'll put -1. And then our common difference is 6. That's the same as our slope. So 6n minus 1 is a rule we can use for that. Okay, tell whether the sequence is arithmetic. If it is, what is the common difference? Write a function rule to represent that. Okay, so we need to subtract the numbers. 11 minus 7 is 4. 16 minus 11 is 5. 22 minus 6 is 6. There isn't a common difference. It keeps going up. So we're going to say, no, it's not. Second one, 9 minus 3 is 6. 15 minus 9 is 6. 21 minus 15 is 6. The second one, yes. And our function rule, since it's an arithmetic sequence, we'll call it a sub n. And that's going to be 6 times n. And then we have to think about what would our 0th term be. This is our first, second, third, fourth. Our 0th term would be 3 minus 6, which is -3. All right, Justine's grandfather puts $100 in a savings account for her on her first birthday. He puts $125, $150, $175 into the account on her next 3 birthdays. If this pattern continues, how much would there be on her 12th birthday? Well, this is a sequence, and we could just keep following this sequence out to the 12th term. This is the first term, this is the second, this is the third, and so on. Either that, or we could just write a rule and then use 12 as our input for that rule. So since it's an arithmetic sequence, let's just call it a of n. And we need our common difference, and you guys probably already figured out that that's 25. So we're going to put 25n there. 25 times n. Plus, we have to figure out what the 0th term would be. So if I went back one term, what would that be? And that would be 75 if I take 100 minus 25. So that's my rule. Now to get her how much he's going to put in on her 12th birthday, that would be a of 12. And to do that, I would just have to do 25 times 12 plus 75. And I think that's equal to 25 times 12 is 300 plus 75 is 375. And if you're not real sure about that, you might just enter your calculator, the numbers, and see if it works out the same way if you just keep adding 25. All right, we're going to talk about one other kind of sequence here, and that's a geometric sequence. And a geometric sequence is a sequence where the ratio of consecutive terms is constant. In other words, you are multiplying by a constant, which when we were studying these in class, we called them exponential. Since we keep multiplying by the same number, we can use an exponent to represent the what we're multiplying by. And so we are multiplying by the same number. All right, so recall that a ratio sequence is a list of numbers that often forms a pattern. Each number in a sequence is a term of the sequence. In an arithmetic sequence, you found each new term by adding. In a geometric sequence, the next term is found by multiplying by the constant ratio. So check this out. Here's a geometric sequence example, and let n be the term number in the sequence, and then a of n is equal to the value of the nth term of the sequence. We really should use g of n since it's a geometric, a new kind of sequence here. What is the common ratio of the sequence? So to get that, you would divide these numbers instead of subtracting those. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is also equal to 3, so there's a common ratio of 3. And our first term in this sequence is equal to 2, which is 2 times 3 to the 0th power. The second term is 6, which is 2 times 3 to the first. And then we get the second, and we get the third power. And then here it says, what is the relationship between the exponent of the base 3 and the value of n? And the exponent is always 1 less than n. So we could write n minus 1 as our rule for the sequence. I'd like to offer that we could also write it as, instead of thinking it the first term at 0, what if we went back 1 and said, all right, so a sub 0 is equal to what? And that way, we'll see in a second. So if we went back 1 term in this sequence, so here's our sequence 2, 6, 18, 54, and we get each new term by multiplying by 3. So if I go back, I'm dividing by 3. If I take 2 divided by 3, I get 0.6 repeating, or 2/3, for my 0th term. So if I start with my 2/3 for my 0th term, then I can just take 2/3 times my common ratio of 3 to the 0th power. And now my zeros match up. My 0 here and my 0 here are the same, so n is the same as the power. I think I like that better. So if I use 2/3 here instead of 2, then I can use 3 to the first. 2/3 here, I can use 3 to the second, and so on. And then I can write this. And I'm using g instead of an a like you see here, but I can say 2/3 times 3 to the nth power, and then I don't have to have n minus 1 for my power, because my power exactly matches up with my term. So if I were you, I would skip this part, and let's just say this, where we have to figure out one thing, and that's the starting value when x is 0. In other words, the 0th term. So in this problem right here, 5 is the first term, 15 is the second, 45 is the third. Our 0th term we would get by dividing 5 by 3. And that's not hard to do. We can just do 5 divided by 3, which is 1.6 repeating, or we can just leave it as 5/3. And so we could have this for our rule. All right? So I'm just going to give you one more example there. Let's say here's my geometric sequence, and I'm multiplying by 2. So the rule for that is, and I'm going to call it g of n, is equal to our starting value when x is 0. So this is my first term, second term, third term, fourth term. My 0th term is my starting value, so I just need to figure out what I'm multiplying by here, which is 2. And then just divide by that to get the 0th term. So 10 divided by 2 is 5, and that's my 0th term. So I'm going to put that there for my a of 0. And my common ratio here is what I'm multiplying by, which is 2, and then to the nth power. And that makes a nice rule for this type of situation. All right, that's the end of the video. You can practice some of those problems. We'll do them in class. I'll see you tomorrow.